Okay, ladies and gentlemen, so the revision video of this one is going to be on completing the square. Now, I think there's only 5 questions, and I'm doing them slightly out of order. I want to start with the easiest ones, and then move on to try and get to the harder ones shortly. Now, when you complete the square, if you've only got a single x squared, then it makes it a lot easier. So what we do is we halve the coefficient of the x. So that's going to be x plus 3, then you put it in square brackets. So it's always going to be x plus or minus something, and then that's going to be squared. So what you do is you halve the number that's in front of the x, it's going to be x plus 3 squared, and then it doesn't matter whether this is plus or minus, and that's the key thing. It doesn't matter if it's plus 3 or whether it's minus 3, you always take away this number squared. So it's going to be take away 9, and then you put whatever this is on the end, so plus 11. You then simplify it, so x plus 3 squared plus 2. Okay, question B. In the space at the top of page 7, sketch the curve with that equation showing clearly any intersections with the coordinate axes. Now, you've also asked me to do a graph sketching video, which I will do, but this one, if you're going to sketch a graph, this is a good revision for it. So if you're going to, well, y equals x squared plus 6x plus 11, you know can be written as y equals x plus 3 squared plus 2. So what I'm going to do here, we're going to start off with looking at the graph of y equals x squared, and let's pretend I can draw properly, and that's gone through at 0. So this is what y equals x squared looks like. Now what we're going to do is we're now going to draw y equals x plus 3 squared. So what we've done is we've replaced the x by an x plus 3. Now when you've got an x replaced by x plus 3, it means it moves to the left by 3. Does the opposite of what you think. So therefore, it's going to go through at minus 3. And if you multiply it out of the brackets, 3 times 3 is going to be 9, so it's going to go through this point here at 9. But the curve that we've drawn isn't just x plus 3 squared, it's x plus 3 squared, then you've got this plus 2 on the end. So what we're going to do is we're now going to draw y equals x plus 3 squared, so the same one that we've just done, then we're going to add 2. So what we're going to do is we're going to move this up by 2. We go up by 1, 2. Means the whole graph is going to be moved up. So this point here, the minimum is going to be minus 3, 2. And then this point, which was 9, goes through at 11, which we should know anyway. And if we don't know that, again, we're sketching y equals x squared plus 6x plus 11. So to find out where any curve or line goes through the y-axis, we set x equal to 0. So y equals 0 squared plus 6 lots of 0 plus 11. So it should go through at 11, which it does. So this green one here is the graph of y equals x squared plus 6 plus 11. Next part of the question, find the value of the discriminant of this. So the discriminant is b squared minus 4ac. And obviously if you've done enough revision, you'll have come across the discriminant dozens of times already. So b is a value of 6, a is going to be 1 because it's the number in front of the x squared. So it's 1 lot of x squared, and it's going to be the plus 11. So b squared, the discriminant is going to be 6 squared minus, then in brackets, always do this bit in brackets, 4 times by 1 times by 11. So it's going to be 36 minus 44, which equals minus 8. Now it doesn't ask you to interpret that, but if your discriminant here is less than 0, so b squared minus 4ac is less than 0, that means that it has no real roots. And again, what that means is that your curve won't actually go through the x-axis. So we saw that when we drew the curve, it looked like that there. I mean, it could look also like that there, or this here, as long as it doesn't go through the x-axis. So that's if the discriminant is a minus number, it will not go through the x-axis at any point. So let's move on. So the next question, again, this one looks a little bit trickier in terms of completing the square. So we've got x plus p squared plus q. So it's going to be x, and either plus or minus, then it's going to be half of the thing that's in front of the x. So if the thing in front of the x is 4k, we divide that by 2. So it's going to be x plus 2k squared. And then it doesn't matter whether the sign is, you've got to take away that thing squared. So 2k times 2k is going to be 4k squared. So you minus 4k squared, and then you put this plus 3 plus 11k on the end. And that's it. Completing the square, you've got x plus 2k squared minus 4k squared plus 3 plus 11k. So the next part, given that the equation fx equals 0 has no real roots, find the set of possible values of k. Now there is another way of doing this using what we've just done. However, as we've talked about it beforehand, let's have a look at the way in which we said before on how to do this. So if something has no real roots, then b squared minus 4ac will be less than 0. So b is the number that's in front of the x, so that's 4k. So I'm going to put that in brackets, 4k squared minus, and again I'm going to put this in brackets, 4 times by a, now a in this case is just 1, and then times by c, which is 3 plus 11k, and I'm going to stick that in brackets as well. And all that is less than 0. So if we simplify this, 4k all squared is going to be 4k times 4k, which is 16k squared, minus, then I'm going to take another step to simplify this bit. That's going to be 4 lots of 3 plus 11k is less than 0. So 16k squared minus, in brackets, 4 times 3 is 12. And then 4 times 11k is 44k, and that's less than 0. Now, as we said on another video, if you've got a minus, the reason that we do this in brackets is because we've got a minus in front of the whole bracket. So just be careful with the signs here. So we're going to make everything negative. So if we do that, that's going to be 16k squared minus, if I sort them around a little bit, minus 44k minus 12, and that's going to be less than 0. And if we simplify this to make it a little bit easier, divide through by 4, that's going to be 4k squared minus 11k minus 3 is less than 0. Now what we've got to do is, says find the set of possible values of k. So we need to find all the values of k that make this thing less than 0. And so we've got a quadratic inequality, and as I have always said about when we've got a quadratic inequality, we sketch it and we find out where the graph is less than 0. So if we factorize that out, I'm hoping that it factorizes. 4k k, that's minus 3, and then plus 1. That's going to give us plus k minus 12k, which is going to be minus 11k. So therefore the solutions are k equals 3, k equals minus 1 quarter, and we know that it's positive and it goes through at minus 3. So our graph looks like that there. Now we want to know where our graph is less than 0. So where it's less than 0 is down here. And that is between 3 and minus 1 quarter. So the possible values of k are when k is less than 3 but greater than minus 1 quarter. Okay. Given that k equals 1, sketch the graph of y equals fx showing the coordinates of any point on at the graph, at which the graph crosses the coordinate axis. So, if we, it would help if I hadn't have, oh no, I've still got it up here. So the completed square version is at the top there, and we've got to sketch this given that k is 1. So what we're going to do is we're going to substitute in k as 1, and then see what it looks like. So that's going to look like function of x equals x plus 2 squared that's going to be minus 4 plus 3 plus 11. So plus 3 plus 11 minus 4. So that's going to be plus 10. So again, just like before, what we're going to do is we're going to sketch y equals x squared, which will look like that-ish. Now this x plus 2 here means that we're going to go 2 to the left. So it's going to be x plus 2 squared. Even though it says plus 2, it means that we go to the left by 2. And then we're going to add 10. So then we're going to go up by 10. So therefore, minus 2, 10 are going to be the minimum points. And we know that it goes through whatever this is here, which turns out to be 14. And that's it. Now, sometimes, if they're feeling a little bit cheeky, they will give you a completing the square to do, whereby you've got a number in front of, or a coefficient of x squared. Now again, this makes it a fair bit trickier. Not impossible. And the thing that we have to do first is to factorize, or to take the 2 outside. So we're going to say that the f of x equals 2 lots of, and then factorize the 2 out, so x squared plus 4x plus 3 over 2. Cool. So my mistake, I'm doing part B first. So we'll do part B and then we'll go back to find the discriminant. So once we factorize the 2 out, we're going to complete the square for inside. So we're going to keep the 2 on the outside. Then, just as before, we do half the coefficient of x. So x plus 2 squared. And then again, we always take away 2 squared. So 2 squared is 4. And then I'm going to put that plus 3 over 2 on the end. Okay, so let's tidy that up a bit. That's going to be equals 2 lots of x plus 2 squared minus 4, which is minus 8 over 2, plus 3 over 2 is going to be minus 5 over 2, my apologies. And then what we're going to do is we're going to multiply the bracket. So we're going to do 2 lots of the bracket, so it's going to be 2 lots of x plus 2 squared. So we don't need to do anything else there, just do 2 in front of this set brackets here. Then we're going to do 2 lots of this thing. So it's going to be minus 5. And that's it. That's how you complete the square when you've got a number in front of it. So 2 bracket x plus 2 squared minus 5, just in case we need that for part C. Okay, so let's go back and do the easier question of finding the discriminant. Then we'll have a quick chat about what that means as well. So discriminant is b squared minus 4ac. So b is going to be 8. So it's going to be 8 squared, which is 64. Minus, then I'm going to put in brackets 4 times by a times by c. So 64 minus 4 times 2 is 8 times 3 is 24. 64 minus 24 equals 40. So because 40 is positive, it means that it's going to have 2 distinct real roots. Okay, so that's 5 out of these 10 marks. So the last one, the line 4x plus c, where c is a constant, is a tangent to the curve y equals f of x. Calculate the value of c. So what does that mean? I mean, let's sketch it and then see if that gives us any clues. So I've got y equals x squared looks like that. We're then going to move it over to the left, so it looks like that by 2. We're then going to stretch it, so it goes up like that. Then we're going to take away 5, so it looks something like that. So it looks, I don't know, doesn't need to be that accurate. This is just for illustrative purposes. What a lovely word illustrative is as well. Okay, so the line y equals 4x plus c, where c is a constant, is a tangent to the curve with this equation. So just to remind you what a tangent is, a tangent is where a line will just touch the curve once. So if the question said, find out where, and they told you what C was, let's say C is 7, whatever it turns out to be. Find the point of intersection where this meets this, there's only going to be one solution because it's a tangent. So, that's what we do. We substitute this into this one, and we know that if we then go to solve it, there'll only be one solution. And the thing we know about when there's only one solution means that the discriminant equals 0. So, let's do that. So we've got 2x squared plus 8x plus 3. We're going to set that equal to y equals 4x plus c. So now we're going to get everything onto one side. So we've got 2x squared plus 4x plus 3 minus c equals 0. And now I know that because it's a tangent, it only touches the curve once. So therefore there's only going to be one solution. So I know that b squared minus 4ac will equal 0. So in this case, b is going to be 4, so it's going to be 4 squared minus, brackets, 4 times 2 times by c, which in this case is 3 minus c. If you've got more than one thing, put it in a bracket, and that will equal 0. So 4 squared is 16. Again, whenever we do 4ac, we always stick in brackets. So that's going to be minus 8 lots of 3 minus c. So it's going to be 16 minus, in brackets, 24 minus 8c equals 0. 16 minus 24 plus 8c equals 0. So that's going to be minus 8 plus 8c equals 0. 8c equals 8, c equals 1. And that's it. That is our value of c. Okay, so let's work backwards then. Question 2, and then we'll finish off on question 1. So find the discriminant again. You can see that discriminant and completing the square tend to overlap a fair bit. So let's have a look at this one. Complete discriminant. B squared minus 4ac. So b is going to be k plus 3, so it's going to be k plus 3 in brackets squared minus in brackets 4 times by a, which is 1, times by c, which in this case is just k. So if we expand this bracket, remember when you've got to expand that bracket, k plus 3, because it's a squared, you do k plus 3, k plus 3. Whenever you have a bracket squared, you write out the bracket twice and use smiley face method. K squared plus 6k plus 9. If you need to do that and take the extra step, then minus, if we multiply this together, it's just going to be minus 4k. So k squared plus 2k plus 9. And now we've got to show that discriminant can be expressed in this format. So we've got to complete the square with what we've just done here. So what we do, just like before, is whatever the number is in front of the k, you halve it. So k plus 1 squared. Doesn't matter what this is, we square it and take it away. So take away 1 plus 9. And if we then simplify that, it's going to be k plus 1 squared plus 8. To show that full values of k, the equation fx equals 0 has real roots. So what we've done is we've just found the discriminant. So if it has real roots, then that means that it can never be 0 or never be negative. There's a few ways to do this. You could do the discriminant of the discriminant and show that it's always going to be positive, or as we've done so many times up until now, let's try and sketch this and show that all the y values will always be positive. So if we're going to do y equals k plus 1 squared plus 8, then y equals k squared, again, will look like this. Plus 1 means it's going to move over to the left by 1. Then we're going to add 8. So if we then move up by 8, we're going to get this here, where the minimum is minus 1, 8. And we can see here, just by looking at the diagram, that all of the y values, all of the values that this could ever be, the minimum is going to be 8, and that's when k equals -1. But all the other ones then are positive. So therefore, you need to say that if f of x equals 0, sorry, no, fx equals 0 will always be positive. So this will always be positive because the discriminant will always give you a positive value if you look at the graph. Something on those lines. Finally, question 1. Now, we've got a complete square here, and this one is a little bit trickier. So what I would do is we've got this number here, the -5, and then we've got to put the other bit in brackets. So that's going to involve the x squared and the 4x. So what I'd do is -5, I just put that bit in brackets. So I would say -5, and then I would minus, and I put in brackets x squared minus 4x. So just get this bit here in brackets. And I'd make it positive by taking the minus outside. So minus times x squared is going to be minus x squared. Minus times minus 4x is going to be plus 4x. Now, as soon as you've got it looking like this, you can then complete the square. So that's going to be x minus 2 squared minus 4. So just like we have done in all the other ones, you're going to complete the square. So then, if we then multiply the brackets, minus times this bracket is going to be minus x minus 2 squared. Minus times minus 4 is going to be plus 4. Then we've got to simplify it. So minus 5 plus 4 is going to be minus 1. So it's going to be minus 1 minus x minus 2 squared. Again, they ask us to calculate discriminants. They do like lumping these questions together, but just so you don't get confused, write it out in order first. So minus x squared plus 4x minus 5. So b squared minus 4ac. B is going to be, so I'd write out b squared minus 4ac, just so that they know, you know that the discriminant means b squared minus 4ac. So I'd write out 4 squared minus, in brackets, 4 times by 8, this time it's going to be minus 1. Minus 1 times by minus 5. So that's going to be 4 squared minus 4 times minus 1 times minus 5 is going to be 20. So that's going to be 16 minus 20, which equals minus 4. Now, because we've got this here, so if we then write it as minus x minus 2 squared and then minus 1, if we write it that way around, the fact that our discriminant is negative means it's not going to cross the x-axis at all. So we can tell by looking at the equation that if you set x equal to 0, y equals minus 5. So before we start, we know that it's going to go through at minus 5. And so what we're going to do is we're going to start off with y equals x squared. We're then going to move it. It says x minus 2, so that means it's going to go to the right by 2. So it's going to look like that there. Is then going to do, you've got to use this minus, which is in front of the brackets. So if you've got a minus in front of that bracket, it means it's going to reflect it. So it's going to look something like that, except more curvy. And then you've got this minus 1, so then it goes down by 1. So then what you end up getting is something that looks like that. This point here is going to be 2 across and then minus 1. Okay, and that is the revision video on discriminant and completing the square.